Hey everybody, today we're going to start our new unit in geometry, and we're going to talk about points, lines, planes, and angles. So let's get into it. All right, so on our first page, there's some terms that we're going to define here for points, lines, and planes. So the first one we're going to talk about is a point. So a point is a location in space. And when you see a point, you see it like on a graph, and then we give it like counting over 1, 2, up 1. So that would be the 0.21. It's actually just a location on that grid. So a location in space. Lines. So a line is never ending. System of points. So basically, when we've done our graphs before and I graph a line is made up of a bunch of points, and it never ends because you have arrows that mean continue in both directions. And then planes. And a plane looks like this. And it can be a rectangle or signified as a parallelogram, but it's actually just a containment or a boundary of space. And it might be called like plane P or with a capital letter, something like that. And you see like a line or you'll see a point in it. And that's what a plane is. So here I have a point. Oops, went too far. And a point is always going to have a capital letter. And then we see a line. And a line, it could have like line AB, which we talked about before with the arrows to signify I'm talking about line AB. Or it could have like a little letter at the edge of one of the arrows, and it could be called line M that way with a small letter. And it's made up of a system of points. So there are an infinite number of points that I can put on a line, and it keeps going because of the arrows. So all the way left, all the way right in that case. And then we have down here, I have a line and I have a ray, and we talked about rays before. A ray has a beginning point or an end point, you might want to call it, and then it keeps on continuing in one direction forever and ever. And when I put a couple of rays together, like these two rays, I formed an angle. When I put together a ray and a whole line, like this, I form two angles. All right, let's talk about the word collinear. Like if you cooperate with somebody, you work with them. Anytime I put co in front of a word, it means together. So co means together. And then you see the math word linear, which means line. So collinear points would be points together on the same line. Non-collinear just means not. The word non is not. So not on the same line. All right, let's move on. So here's a depiction of a plane. And in that plane, I have coplanar points. So we just talked about co means together. And then I see the word plane here, or part of the word plane. So that means together on the same plane. So what points are coplanar here? All the points that are in the plane M. So we have point A, point B, and point C would be coplanar, not point D right here. It's outside of the plane. It's a point outside of the plane. All right, non-coplanar points, I could pick any point that's going to be non-coplanar, not on the same plane as D. So D and any of the other ones would be non-coplanar. All right, and then I see that I have a little triangle over here, and all these vertices are technically points also. So one is called a vertex, so this is like vertex Z or point Z. If I'm talking about many of them, they're called vertices. More than one, it's just plural. All right, a line consists of at least, so to make any line, if I have one point, I can make a whole bunch of lines through it, an infinite number. If I have 2 points, there's only one line I can make that goes through those 2 points. So a line consists of at least 2 points. A plane has to have at least 3 points to make a plane. So I have to have at least 3 things or 3 points to make a plane. Otherwise, if I only have 2, I've only made a line, one dimension to go around it. So at least 3. Space. So the space is like an area of something. An intersection is where I could say 2 lines, 2 planes, 2 of something meet or come together. All right, now here gets into what we're going to be doing in the IXL. The intersection of 2 lines. So if I take any 2 lines, like if I just draw 2 easy lines, like let's say a vertical one and a horizontal one, they intersect right here at a point. So 2 lines intersect at a point. So I can even see this right here in a 3D picture. If I follow this line, and actually it's a line segment because it ends, and I follow this line segment, I see they intersect right here at a point. All right, the intersection of 2 planes. So for 2 planes, I would think about this. I would think about, let's say 2 walls coming together in the classroom. So if I look at 2 walls, and then I see another wall coming out from that, if I look in that corner right here, where they intersect, it makes a line. So now let's see what that looks like in a 3D picture. So in a 3D picture, if I have this plane that's facing me right here, and I have the top of the box, which is this plane coming together and meeting that, I see that they intersect and they make this common line or the edge of the box. So 2 planes coming together make a line. And then the last one, the intersection of a plane and a line not on the plane. So if I have a plane, like let's say if I have a piece of paper and I stick my pencil down through it, right through the center, it's going to go right through and make a hole, and that hole is a point. So same thing in a 3D picture. If I have let's say I have an arrow and I'm shooting it right through this box, here's my first plane on the top. And if I go through that, it's going to make a hole right there. It's a point. And then when I go through the bottom, it's going to make a hole. That's another point. So anytime I have a line that's not inside the plane, that's coming through it, like coming through a piece of paper, then I've made a point for my intersection. All right, so let's take a look at a couple of these together. So the first one says Z is on line AB. So I'm going to find Z right here. And is it on the line AB? Well, yes, it would be, because AB, just like that, is a line segment, but I see that I can extend out and I can extend out, and it would be on that line. So that's going to be true. AB, line AB contains point Z. So let's see, here's line AB, and yes, Z is on that point, so that would be true. AB passes through Z. So AB passes through point Z. It does. It keeps on going forever and ever because it's a line. AB, so line AB and line CD intersect at Z. So let's take a look at that, and let me erase what we've already done. So let's see what we have. Line AB, so let's find it. I'm going to highlight that whole line. And line CD, so I'm going to highlight this whole line. They intersect at point Z. Yes, two lines intersect at a point, and those happen to come together at Z, so that is true. All right, now let's talk about a plane. Plane M contains line AB and point Y. So let's take a look at it. Plane M. So first I'm going to look for an M. And let's see where that would be. So here's my M. So I'm going to do this plane around it and highlight it. And then it's asking me about what's in that plane. So it has to contain line AB. So let's see if it does. Yes, AB's in there in that plane. And point Y. And here's point Y. So that is true. All right, next question. CD intersects. So let me erase here. And let's highlight the new line. So CD, here's my line CD, intersects the plane M at point Z. So yes, if it was cutting right through there, it would intersect, just making a hole right there. So that would be true. All right. M and N, points M and N intersect in EF, so on line EF. So let's find M and N. So M is my whole plane. Let's erase this. And let's highlight what we're talking about. So plane M right here. And plane N. Let's find plane N. So here's my N. So if I put these two planes and I make one go right through, the vertical one go right through the horizontal one, like cutting a slit and putting a piece of paper down through another sheet of paper, it says that those two planes intersect at line EF. So let's see. Yes, they would come together right here at EF. All right, that is true. And technically, they have EF as a line segment, so it should read EF like this. Not with arrows. Little mistake they got there. All right, then this says line EF, so it should be line segment EF, is the intersection of plane M and N. We've already answered that. It's the same question as above. And yes, it is. All right, and then plane M and N contain line EF. Yes, because it's the intersection of both of them, so it's in both planes. All right, and then I'm going to give you a minute, and you're going to try this 1 through 13, and we'll see how we do. We'll come back together, and then we'll work on the bottom part. So let's stop this here.